Welcome to this Electricity and Verdine presentation. Today we will learn about the economy behind the proper PC power management. So this is the three power states a modern computer can be on, and you know that they spend like 100 watts when they are on, but do you know how much do they use in energy when they are in low power state? A low power state in a computer is almost 96% less than when they are left on. So this is the main concept you should learn, because it's really powerful to realize that by putting the computers in a low power state without putting them off, you will be saving this huge amount of energy. So regarding the faulty states, if you have computers on during the off hours, you are losing money. How much money? If you leave 4 computers all day long on, you will spend like €1.44 per day. In contrast, if you have computers that are not responsive when you want them to be on just to do maintenance in the network, you can have almost 25% of stupid computers, or computers that are not well maintained or they are not up to date. So let's see a case where we compare the screen in the left that's more efficient than the screen at the right. If we leave them off the whole year, this is the energy they will spend, and if we leave them on the whole year, this is the amount of energy they will spend. But what does this mean in the budget? Is that you will save a cup of coffee a year per screen just for leaving them off all year, the efficient one versus the inefficient one. But if you leave them on all year, what happens? Oh, you can save a coffee and a sandwich. This is ridiculous compared to the amount of money a company spends. 10,000 people that earn €1,000 a month can spend 140 million euros in salaries. So you can see for yourselves what does it mean to switch computer screens to save energy. So what we have in the real world, this is a graph in a bank in Spain in 2011. We can see here that the utilization hours before policies are applied with Verdine Surveyor are 12 hours. Then we reduce that to 6 hours just to putting them in low power states after an hour of inactivity from the user. And if we return to the efficient screen unmanaged versus the inefficient one but managed with Surveyor, we see that we can save way more money by using any screen but managing it with Surveyor than buying a new screen but leaving it as it is without management in place. This takes us to the myth or the misconceptions there are about the calculations. When we ask energy services companies how do they calculate the energy spending in a computer network, they use average numbers. They multiply the power consumption of the PCs by the hours they are supposed to be working because of the habits of the users, and this is the number they give to your company, and they charge you for consulting services to explain you this, and this is okay. But it's not enough when we arrive to the IT department. People think that they don't have any problem, and when they realize they have the problem, there can be a problem, they ask you for the proof. Which are the numbers? So these numbers are based on the capability we have of measuring the energy states consumption in each one of them physically. We measure a set of computers that represent your network, and then we input this data inside Surveyor, and Surveyor groups the computers by families and can know then for one individual computer each day the amount of time it has been in one of these states. So it multiplies the time per the state, and this gives you the consumption, and you can see the savings also. So this is really simple, but it's way much better than the usual stuff that energy services companies does. So the main concept you have to retain is this one. It's silly to be discussing numbers and precision when you don't have any idea about how much time your equipment is spending in one of the energy states, or when you can have computers on when there's no need at all for them to be there and you don't know that. So this is the main concept. I hope you have learned something useful with this, and I want just to say thanks and welcome to next videos we will publish here in YouTube.